Okay, we can do kind of just a combination video solution set for both Algebra 2 and the honors class. Here's a problem that would be just only for the regular Algebra 2 classes. Write the simplified standard form equation of a circle with center at -8, 3, and radius 1. So let's remind ourselves real quick that the standard form equation of a circle is just x minus h squared plus y minus k squared equals r squared, where h and k are the coordinates of the center of the circle and r is the radius. So all we'd have to do here is just plug in -8 for h. So I'd get x minus -8 makes x plus 8 squared plus y minus k is 3 squared equals 1 squared, which is 1. And so that is what I would enter in Moodle. That would be correct. Okay, here's an example of a problem that would show up on both the Algebra 2 and the Honors Algebra 2 4.1 practice. Write the simplified standard form equation of the circle with center at 6, 2 and containing the point -3, -4. So once again, x minus h squared plus y minus k squared equals r squared. Well, they're giving us a value of h and k. So we know that we'd end up with x minus h, which is 6 squared, plus y minus k, which is 2 squared, equals r squared. So we know h and k, but we don't know r. We've got to find r by plugging in a solution. Well, we're told that this is a point on the circle, so that's a value of x and y that should work in our equation. So if I plug in an x value of -3 and a y value of -4, that's going to allow me to solve for r squared, which is the number that has to appear on the right side of the equation. So what do we get? -3 minus 6 is -9. -9 squared is 81. -4 minus 2 is -6. Squared is 36. 81 and 36 is 117. And so, I did that right, yeah. So then we'd end up with r squared equals 117. And so that's the value that we would plug in on the right side of the equation. So our equation would become, and this is the answer we did put into Moodle. The answer would be x minus 6 squared. We got to write this in terms of, with x's and y's, with the variables in the equation. So x minus h squared plus y minus k, which is 2 squared, equals r squared, which is 117. If we wanted to calculate the radius, it would just be the square root of 117. But that's not what we were asked to do. We were just asked to write the simplified standard form equation of the circle, and that is it. Okay, this is another one that would apply to both Algebra 2 and Honors. So we got to write the simplified equation of the circle in standard form. So we want to put this once again in the form x minus h squared. X minus h squared plus y minus k squared equals r squared. Okay, so I'm going to have to complete the square for both the x's and the y's. Well, actually, not for the x. There's only one x term that's x squared. So that's my only x term. So that tells me that h is 0. Okay, but I have to complete the square for the y's. There are 2 y terms here, and I need to build those into a perfect square. So we're going to write that as, we'll collect those terms together, y squared plus 2y and leave a space. And then we're going to push we're going to add 8 to both sides to get the constant on the right. And so this would be equal to positive 8. And so then we just need to complete the square for the y's. Half of positive 2 is positive 1. 1 squared is 1, so I have to add the red number 1 to both sides. So we end up then with x squared plus the quantity y plus 1 squared equals 9. And that's standard form. Okay? So that's what I would input into Moodle. How come there's just an x by itself? Well, because h is 0. We're subtracting 0 from x. Okay? Here's another one that would apply to both Algebra 2, Honors Algebra 2. So what about this? Well, one thing we can do right away that would make this a lot easier on this problem is I can divide both sides through by 10. What's that give us? Well, dividing the whole left side by 10 means I'm just dividing each of these terms by 10. So the first term is going to give me x squared plus y squared minus 60 over 10 is 6x, 80 over 10 is 8y, and then dividing 210 by 10 means I just cross off a 0, so I get 21. Okay? So then we want to, same as before, we want to collect the x terms together. So we're going to get x squared minus 6x space plus, let's collect the y terms together. Y squared minus 8y space equals, and then we'll just subtract 21 over to the right side. And then we're just going to complete the square for the x's and the y's. So if we complete the square for the x's, half of negative 6 is negative 3. So we can see that h is going to be 3. Negative 3 squared is 9, so I have to add the blue number 9 to both sides. If I complete the square for the y's, half of negative 8 is negative 4. Negative 4 squared is 16, so I have to add 16 to both sides. And what do I get? Well, negative 21, 9 and 16 is 25, sorry. Minus 21 is positive 4. So there it is. That's my answer. That's in the form x minus h squared plus y minus k squared equals r squared. Okay? Okay, here's an example of, this is just only for the Algebra 2 class, not the honors class. So now we're going to try some little different type of problem on the problem set. We're trying to identify the center and the radius of the circle. Well, this is given to us. Notice that this equation is given to us in standard form. What's the number being subtracted from x? This tells us that h is 0 because nothing is being subtracted from x. This tells us that k is 1 because 1 is being subtracted from y. And 81 is r squared, so that tells us that r equals the square root of 81, which is 9. So the center of the circle is at the point 0, 1, and the radius of the circle is 9. Okay, this would apply to both classes, honors and algebra 2, both. Same kind of thing, only this time they didn't give us the equation in standard form. We have to complete the square. So we would have to collect the x terms together, leave a space, collect the y terms together, space, equals, and then we'll subtract the 43 over to the right side. If we complete the square for the x's, half of -8 is -4. So we can see already that the center of the circle, the h value is +4. That's the number that's being subtracted from x. Because remember, we're just comparing this to the standard form. X minus h squared plus y minus k squared equals r squared. Okay, but to get this, going back to the algebra here, half of -8 is -4, but to get that, I have to add 16, which is -4 squared, to both sides. If I complete the square for the y's, half of -12 is -6, and -6 squared is +36. So I add 36 to both sides. That tells me that the y coordinate of the center, which we call k, is 6. And then what do I end up with on the other side? 16 and 36 is 52, minus 43 is 9. And so r squared is equal to 9, so r is 3. That's it. Okay, this is an honors problem. You can ignore this one. If you're in the Algebra 2 class and you're watching this, you can pass by this one if you want to, or you can watch it if you want to and see if you can follow along. So same kind of a thing here. We got to put this in standard form. So we're going to collect the x terms together. So 16x squared minus 8x space plus collect the y terms together. 16y squared plus 48y space equals, and then I'll add the 27 over to the right, like so. So what do we get here? Oh, whoops. Sorry, start over. I'll blame it on my cough medicine. What can we do to this? If we're going to complete the square for both the x's and the y's, and we're going to produce the standard form equation of a circle, then we know that whatever the coefficients of x squared and y squared are, they're going to be the same. They have to be, because this, remember, is going to give us the standard form x minus h squared plus y minus k squared equals r squared. So I have to first, before I do anything, I have to divide this whole thing by 16, because I need this to be in the form just an x squared by itself, right? Because I'm going to complete the square and get the quantity x minus h squared. So that's going to make this look good. Then I'm going to get x squared when I divide each term by 16 plus y squared. 8 over 16 becomes 1/2 x. 48 over 16 becomes 3y minus 27 over 16 equals 0. Right, so now we'll complete the square. So we'll collect the x terms together, x squared minus 1/2 x space, plus collect the y terms together, y squared plus 3y space equals, and we'll add the 27/16 over to the other side. Okay, so if we complete the square for the x's, we end up getting half of -1/2 is -1/4. So x minus 1/4 squared is what we're going to get for our perfect square. So we can see right away here that, well, I guess we're just putting it in standard form. If we were looking for the coordinates of the center, the x coordinate which we call h is 1/4. To get this, I have to add negative 1/4 squared, which is 1/16 to both sides. Now let's complete the square for the y's. Half of positive 3 is 3/2. 3/2 squared is 9/4. So I'm going to add 9/4 to both sides. Then what do I get over here? 27/16 plus 1/16 is 28/16 plus 9/4. Well, if I multiply top and bottom to get a common denominator, actually I could reduce this, couldn't I? Let's just do that. So 28/16, if I divide top and bottom by 4, I get 7/4 is what those two combine to, plus 9/4 gives us 16/4, which is 4. So the final answer in standard form would be x minus 1/4 squared plus y plus 3/2 squared equals 4. So that's what I would input in the middle. So we can see the center of the circle has coordinates 1/4, negative 3/2, and the radius is 2. Okay, this is also an honors level question. We want to find the center of this circle. Okay, so we're going to do something very similar. We have to divide both sides by 8 so we can get the x squared and the y squared terms. So we can get rid of the coefficients of x squared and y squared. That's a good way to say it. So what do we get? If I divide each term by 8, we end up with the equation x squared plus y squared minus 2x plus, what is that, 12y plus 21 equals 0. Okay, so let's collect the x terms together. Space plus, we'll collect the y terms together. Y squared plus 12y space, and we'll subtract the 21 over to the other side. Now we'll just complete the square, both x's and y's. So x, half of negative 2 is negative 1. So we can see that the center of the circle has an x coordinate of 1. That's the value of h. To get that, I have to add negative 1 squared, which is 1 to both sides. And let's see here. For the y's, half of 12 is 6. So we can see that the value of k is negative 6. To get that, I've got to add 6 squared, or 36, to both sides. So we end up with, what do we get here? Negative 21 plus 1 is negative 20, plus 36 is 16. And so the square root of 16 is 4. You know, I'm not sure why that actually would apply to both classes. That's not just the honors class. That would work for both. Okay, and then last one is just an example of one where we're trying to find the graph of this equation for a circle. And so this is just the stuff we've been doing. Whoops, we're just going to identify the values of h and k and r by putting the equation in standard form, and then pick the circle that corresponds to those values. So to do this, we're going to collect the x, well, there's only one x term, so that's easy. So we get x squared plus, let's collect the y terms together, y squared minus 4y space equals, and then we'll add the 32 to the other side. So that gives us x squared plus, if we complete the square for y, half of negative 4 is negative 2, and negative 2 squared is 4, so I gotta add 4 to both sides. And so there's my standard form equation. So what's that tell me? Well, this tells me that, this term tells me that h is 0. Nothing is being subtracted from x. This factor here tells me that k is 2, because that's the number being subtracted from y. And r squared equals 36, so this one tells me that r equals the square root of 36, which is 6. So we've got a center at the point 0, 2, with a radius of 6. So all we got to do is go find that point, or go find that graph, sorry. So 0, 2, radius of 6. Okay, that looks pretty good, doesn't it? So there's the center at 0, 2, and the radius is 1, 2, 3, 4, 5, 6.